Okay, so let's move into the topic known as the binomial theorem. But before we get there, we need to talk about something else called factorials. Why? Because the binomial theorem uses these things called factorials. So let's look at the definition of a factorial. First off, the notation is this exclamation point. So if you see n factorial, or n with an exclamation point, that means n factorial. And by definition, that says take the number, whatever it is, and multiply it by all the numbers that come before it until you get to the 1. This is a multiplication problem. For example, look at number 1, 5 factorial. It means that we are going to take the number 5 and I'm going to multiply it by all the numbers that come before it. So like 5 minus 1, 5 minus 2, 5 minus 3, 5 minus 4, right? All the way to 1. Okay, we stop at the 1. Because if we go beyond that, you end up with a 0, and anything times 0 is just 0, so that doesn't help us, right? Okay, so clearly you're just going to multiply 5 times 4 times 3 times 2 times 1. And you get? Good. 120. Okay, let's look at the second example. 7 factorial, because that's what the exclamation point means, which says we're going to take 7 and multiply it by all the numbers that precede it. Agreed? You're like, hey, I like this. Of course, so do I. It's very easy to do. So when you multiply these, you get, good, 5,040. Now this one, number 3 over here, this one's practically not so bad to work with. Stay off the calculators, just hang in there. So what does 8 factorial mean? Yeah, it means 8 times 7 times 6 times 5, right? All the way till I get to 1, correct? Okay, what does 5 factorial mean? Yeah, 5 times 4 times 3 times 2 times 1, right? Notice something, this is a division problem. Do you notice you can cancel? Yeah, 5, 4, 3, 2, 1, see ya. Which means all you have left to do is actually multiply 8 times 7 times 6 in order to figure out what 8 factorial divided by 5 factorial is. And you get? Good, 336. Now, what happens if we said negative 3 factorial? Check it out. By definition, I would take negative 3 and then multiply it by negative 3 minus 1, wouldn't I? And then by negative 3 minus 2, right? All the way till I get to 1, right? Okay, but I need you to see something. This would be negative 3. This parenthesis would be what? Yeah, negative 4, negative 5. Are you ever going to get to 1? No, you won't. So can you take the factorial of a negative number? No, you can't. This one does not exist. Got it? Okay, hang in there though. Wait a minute. I got something else I want you to notice. So I cannot take the factorial of a negative number, can I? But what happens if they wrote it this way? Number 5 here. What am I taking the factorial of? Am I taking the factorial of a negative 3 like I did in number 4? Good. Some of you said no, and some of you are like, I'm not sure. Okay, hold on. On number 4, how do I know I'm taking the factorial of a negative 3? Good, because there are parentheses there, right? There are parentheses holding the negative with the 3. So clearly I'm taking the factorial of negative 3. Over here on number 5, is that negative attached to the 3? Good, it's not. Why not? Because there are no parentheses around the negative and the 3, which means in this case on number 5, you are literally doing 3 times 2 times 1. And the negative is on the outside here, just hanging out, going, okay, I'm still here, just waiting for you to remember me. So you have 3 times 2 times 1, which is 6, but the answer is a negative 6 because the negative was on the outside. On number 4, the negative and the 3 are attached because they're in the parentheses. Good? Okay. One more for you. 0 factorial. Yeah, you're like, I know. This answer is 1. Just like anything to the 0 power is 1, 0 factorial is also 1. Good? Okay, hang in there. I got another notation for us to go over. Here's another notation, and it's read n choose x. And by definition of this notation, n choose x, it's rewritten as n factorial divided by x factorial, and then the difference between the two numbers, factorial. Now, here's the one thing that we need to make certain about this. N has to be larger than x. Why? Because here, if n is not larger than x, then I get a negative number, don't I? And we already saw, like just a few moments ago, you can't take the factorial of a negative number. Remember example 4, you can't. So, n must be larger than x. So let's look at this first example, okay? They're asking us to simplify 10 choose 3. So by definition, we have 10 factorial over 3 factorial, right? That's the n and the x. And then we're multiplying it by the difference of the two numbers. So this is 10 factorial over 3 factorial times 7 factorial, yes? Okay, stay off the calculators. Watch. 10 factorial is what? Yeah, 10, 9, 8, 7, 6, right? All the way till we get to the 1. Agreed? 3 factorial? Yeah, that's 3 times 2 times 1, right? 7 factorial? Yeah, that's 7, 6, 5, 4, 3, 2, 1. Some of you are like, okay, I know where you're going. That's good. I'm glad you know where I'm going with this. Because I'm canceling 7, 6, 5, 4, 3, 2, 1. Right? But you know what else I notice? I'm canceling the 2 and the 8, which gives me 4. I'm canceling the 3 with the 9, which gives me 3. So in actuality, I'm multiplying 10 times 3 times 4, which equals 120. Like, wait, what? Rewind it. Factorials are fun, especially when you're dividing, especially when you're doing n choose x, because there's a whole lot of canceling happening here that makes it very easy for us to work with. Okay, let's look at number 2. 9 choose 7, right? Okay, so that's 9 factorial over 7 factorial times 9 minus 7 factorial, right? Okay, so that's 9 factorial over 7 factorial times 2 factorial, right? Okay, so watch how I do this, and you might like this a little better. Well, isn't 9 factorial 9 times 8 times 7 factorial over 7 factorial times 2 factorial? Notice the 7 factorials cancel, don't they? Which means this is 9 times 8 over 2 times 1. And when you do your canceling, you realize you're just doing 9 times 4, which is, yep, 36. Does this make sense? Yeah, these guys are a lot of fun because it's a whole bunch of canceling, and it takes longer to do on the calculator than it does just to figure it out by hand like this. And the reason we're going over these n choose x is because they're used in the binomial theorem, which I'll be right back with. Okay, so let's talk. Binomial means 2, correct? 2 terms. So let's take a look over here at a plus b to the power of 2. Now, we have done this so often. You write the parentheses out twice, you distribute. And this particular problem, as I said, we've done it so often, we know that we get a squared plus 2ab plus b squared, right? Our challenge arises when the power gets higher than 2. Because now I'm like, what do I get here? I'd have to write this out 3 times and then do my distribution. And if I'm not paying attention, I could make a mistake. So I get that. The one thing you do know is that's going to start with an a cubed, right? And you know it's going to end with a b cubed. Agreed? Okay. So here's the deal though. Remember, you've got descending order, don't you? And as one variable descends, the other one ascends, doesn't it? So you know your next term is going to have an a squared. And then it's go down to an a to the power of 1. And technically, there's an a to the 0 power. Are you with me? We never write the a to the 0, but it's there. Because anything to the 0 power is what? Yeah, it's 1. So we never think about writing it, but it is there. So now the a just descended, and the b will ascend, won't it? Now we usually don't write the b to the 0, but it's there. And then, yeah, this one has b to the first, b to the second, and then b to the third. Now our challenge arises with trying to figure out what the coefficients are. If I could get the coefficients easily, that problem would be very easy for me to get the answer to. So, the binomial theorem helps us with this. Got it? Okay. Now, here's the first thing I'm going to do. First thing I'm going to do is I'm going to write down my terms. Just like here, I wrote down my terms, and then I'll go in and fill in those coefficients. Okay, one thing I'd like you to notice up here, and you know, most people don't know this, but when you have 2 variables in a single term, the sum of these powers always equals the original power. The sum always equals the original power. Are you with me? Every single one of these, the sum of these 2 powers always equals the original one. Got it? Okay, let's look at this one. First things first, I need to come up with my terms, which means you know you're going to start with a to the n, right? And b would have to be to what power? Good, 0, because n plus 0 is n, right? Okay, and then a will start decreasing 1 at a time. So we have n minus 1, don't we? B would have to be to what power? Good, the first power. Because as A descends by 1, B ascends by 1. And by the way, n minus 1 plus 1 equals n, doesn't it? Good. The next term is a to the n minus 2. It keeps going down by 1. And b would be to the power of, good, 2, because it keeps going up by 1. And when you add these 2 powers, you get n, don't you? And this happens all the way down to where we have a to the power of 0 and b to the power of n, don't we? Okay. Now, coefficients is really where we need some help, because unless I want to write this out 3 times, or you know, if the power on here is 10, oh my gosh, really? That's where we really need the help. So the coefficients, that's where that n choose x came in. So watch, don't write, just watch. So the coefficient is going to be that format of n choose x. N is always the degree. The x, the second number, is always the power of the second variable. Whoops. In this case, it's n choose 0, because 0 is the power on the second variable, on the b. You with me? Okay, if I want the coefficient here, the top number is always the original power, which is n. The x part is 1, because that's the power on the b, the second variable. With me? Is this making sense? Okay. Over here, what do you think it would be? Say it again. Good. N choose 2. the original power, and the 2 from the b. And over here, what do you think? Yeah, n, choose n. N, the original power, and this n came from the power on the variable b. Got it? And last but not least, you're like, what about signs? Last but not least, you attach them all with addition signs. If it's supposed to be subtraction, it will work itself out. Good? Hang in there. I'll be right back with an example. Let's look at these set of directions. It asks us to expand. What does that mean? Well, you got 2 choices, but both choices end up in the same spot. You can take this binomial, write it out 5 times, and do your distribution and see what polynomial you get. Or you can use the binomial theorem to help expand this binomial to the power of 5. Got it? So which way do you want to go? I'm going to choose the binomial theorem because it works every single time, and I understand that the binomial theorem really helps me get the coefficients that I need. Because I know what the terms look like. It's the coefficients that I don't know about. So here's the thing. We're going to be very methodical about how we expand these. And then we're going to do it just like I showed you in the theorem. The first thing we're going to do is we're going to find each term. Now, my first term is an x. My second term is a positive 2, isn't it, in this binomial theorem? So we know the first term is going to have x to the power of 5, right? And technically, 2 would be to the power of 0. Excellent. Because 5 plus 0 is still 5. Good? Okay. The second term, x would be to what power? Good, 4. Which means 2 has to be to the power of 1. Great. Because as the x's go down by 1, the powers of 2 go up by 1. And remember, 4 plus 1 is 5. Okay, so after that, x to the third, good, and 2 to the power of, good, 2. Still to the fifth, right, when you add these guys together. The next one, yeah, x to the power of, whoops, see what happens? That's why I need you guys working on this with me. It's easy for the brain to go in the wrong direction sometimes. X's are going down, so x to the power of 2, and the 2 is to the power of 3. Good, still power of 5 when you add them. Like, how do you know when you're done? Remember, you have to end up with x to the 0, because x's are going down from 5 to 0. And I just ran out of board space here, so I'm going to write it down here. So next, we have x to the power of 1, and 2 will be to the power of 4, good, because the 2's keep going up by 1. Their powers keep going up by 1. And we finally get x to the 0 and 2 to the power of 5. Great. Are we good? Okay. Next, we have to figure out the coefficients. So, remember, it's this n choose x notation. So what's n? For every single one of these, what will your n be? Yes, 5. It's always the original. And what's this number going to be? In this term, it's going to be 0 because 0 is the power of the second variable. Here, for this particular term, good, 5 choose 1, the power on the second variable. On this one, what would it be? Good, 5 choose 2. This one, 5 choose 3. Right? This one, 5 choose 4. And last but not least, 5 choose 5. And the last thing you have to do is attach it with signs. And remember, the signs you attach with will always be addition. If it's supposed to be subtraction, it'll work itself out. Does that make sense? Okay, so now here's the deal. We need to figure out each of these coefficients. I need to figure out what 5 choose 0 is, and 5 choose 1, and 5 choose 2, and 5 choose 3, and 4, and 5. With me? So, I got some board space down here. Let's look at this a little bit. If we work on 5 choose 0, that would be 5 factorial over 0 factorial times 5 minus 0 factorial, isn't it? Okay, 5 factorial over, what's 0 factorial? 1. 5 minus 5 factorial? 5 factorial. So what do you think you get here? Yeah, you're just going to get a 1 here because these 5 factorials drop out, don't they? Good. How about 5 choose 1? So 5 factorial over 1 factorial times 4 factorial. Some of you are like, wait, how'd you get the 4? Remember, this second parenthesis is the 5 minus 1. So 4. Are we good? Okay, so 5 factorial is 5 times 4 times 3 times 2 times 1. 1 factorial is just 1. 4 factorial is 4 times 3 times 2 times 1. Looks like these are canceling out, so I just get a 5 here. Does that make sense? Okay. We still have to do 5 choose 2. So that's 5 factorial over 2 factorial times, 5 minus 2 is 3 factorial. So, again, 5, 4, 3, 2, 1. 2 factorial is 2 times 1. 3 factorial is 3, 2, 1, and they cancel, don't they? The 2 goes into the 4 twice, so you have 5 times 2, which is 10. Excellent. How are we doing? You getting the hang of canceling these guys? Yeah, it's quicker for you to do it by hand than the calculator sometimes. Okay, so I'm on 5 choose 3. So 5 factorial over 3 factorial times, good, 2 factorial, getting the hang of it, 5 minus 3, right? Now wait, doesn't this one look like this one? Except the denominators are the numbers are in reverse order in the denominator, but they're still multiplication, right? So, don't you think we should just get 10 still? Yep, we do just get 10. Okay? We still have to do, and by the way, let me do this. We still have to figure out 5 choose 4, don't we? I got some board space up here. Let's figure it out. So that's 5 factorial over 4 factorial times, 1 factorial, right? Wait a minute. That one looks familiar too. Isn't it basically the same one as here, except again the denominators are in reverse order? So what did we get here? I got a 5, so what am I going to get here? 5. Well, that's rather nice. I don't have as much work to do as I think I did. And we have one more. We have to do 5 choose 5, which is 5 factorial over 5 factorial times, 0 factorial. Wait, that one looks like this one. Which, we're just going to get 1, aren't you? We just figured out our coefficients, didn't we? Woohoo! Okay, hang in there. I'll be back with the conclusion of this problem. Okay, so let's finish off this problem. We just figured out these coefficients. 5 choose 0, 5 choose 1, 5 choose 2, etc. Correct? Okay, so let's look down here. What did we get for 5 choose 0? We got 1. So we're going to do 1 times x to the 5th. 2 to the 0 is what? Just 1, right? Okay. The second term. What did we get for 5 choose 1? We got 5 times x to the 4th times, what's 2 to the 1st? Good, 2. Plus our third term. What's 5 choose 2? What do we get? Good, we got 10 times x to the 3rd times, 4. Because 2 to the power of 2 is 4, right? Okay. And the next one was 5 choose 3. What did we figure it out? We figured it out to be 10 multiplied by, x to the 2nd multiplied by 8. Excellent. And then we have got 5 choose 4. What did we get? We got 5 times x to the power of 1 is just x, and 2 to the power of 4. Yeah, that's 16, right? And then the last term turned out to be, what's 5 choose 5? 1. What's x to the 0? 1. What's 2 to the 5th? 32. So, when all is said and done, we end up with x to the 5th plus, 5 times 2, 10x to the 4th plus, 10 times 4, 40x to the 3rd plus 80, because we had to do 10 times 8, x squared, plus, 5 times 16 is also 80, x plus 32. That's the expansion of the binomial x plus 2 to the power of 5. Good? This moves quicker when you get the hang of it, but for the time being, go slow. I'll be right back with another example. Let's look at the second problem. So the directions still say to expand. So now I've got to take this binomial to the power of 6. So you can write that out 6 times if you like. I ain't going to do it. I'm going to go straight to the binomial theorem. So remember, first things first, you establish the terms, right? So 3x is my first variable. -1 is my second variable. So I'm going to start with 3x to the power of 6, correct? And that second variable is at a 0 power. So, because we know 6 plus 0 is 6, right? Okay. The next term has 3x to the power of 5 and -1 to the power of 1. Good, you're getting the hang of it. The next one is 3x to the power of 4 and that -1 to the power of 2. I'm with you. The next one is 3x to the power of 3 and the -1 to the power of 3. Good. We're both agreeing. Remember, the 3x is descending. 6, 5, 4, 3. Good. This is 2. And the -1 is ascending. 0, 1, 2, 3, 4. Good. And these two powers add to 6. The next one is 3x to the first, and -1 is to the power of 5. And I finally have 3x to the power of 0 and -1 to the power of 6. We good? Okay. Coefficients are next. So the n for all of these will be what? 6, because that's the original power. So in this case, I have 6 choose 0. Excellent. The second power. This one I've got 6 choose 1. Good. That's that power. 6 choose 2. You guys are getting the hang of it. 6 choose 3. 6 choose 4. No, that's not a negative sign. 6 choose 5. And last but not least, 6 choose 6. Remember, that second number, that bottom number, is always the power on variable number 2. And last but not least, you always attach them with addition signs, because if it's supposed to be subtraction, it will work itself out. Yes? Okay, and now we get to figure out all our coefficients. Lovely. So we have got to figure out 6 choose 0, 6 choose 1, 6 choose 2, 6 choose 3, and you know, I'm hoping some of these will end up duplicates like they did the last problem. So let's start with these 4. Okay, 6 choose 0. 6 factorial over 0 factorial times 6 factorial. Good. Which is just 1, isn't it? 6 choose 1. 6 factorial over 1 factorial. Good. Times 5 factorial. Okay, so see if you remember what's going to happen here. Yeah, 1 factorial is just 1. But what happens with the 6 and 5 factorials? Good. The 5, 4, 3, 2, 1s cancel, don't they? So in this case, you just end up with 6 on the top. and 1's on the bottom, right? Good. Let's look at this one. 6 factorial over 2 factorial times 4 factorial, right? Okay, so what can you cancel? Yeah, the 4, 3, 2, 1s, which means on the top you have 6 times 5. This guy dropped out because that was a 4, 3, 2, 1. And you still have 2 times 1, which would give you 15, wouldn't you? Okay, 6 factorial over 3 factorial times 3 factorial. What's going to happen? Yeah, the 3 factorial will cancel out from the top and the bottom, and you're still left with a 3, 2, and 1 on the bottom, aren't you? Okay, so me, I like to cancel. So what do we get? We get 20 here. Okay, so we have to do 6 choose 4 now, don't we? And 6 choose 5, and 6 choose 6. Okay, 6 choose 4. 6 factorial, that's right, over 4 factorial times 2 factorial. Oh look, it looks like this one, doesn't it? The 6 factorial on top and the 4 and 2 factorials just switched on the bottom, didn't they? But it's still multiplication, so it's good, right? So we're just going to get 15 here. Okay, 6 choose 5. 6 factorial over 5 factorial times 1 factorial. Hey, that looks like this one. Yep, you're just going to get a 6. And this one is 6 factorial over 6 factorial times, 0 factorial will look just like that one, which means you get a 1. We just figured out our coefficients. Hang in there. I'll be right back with the finale of this problem. Okay, so let's start putting stuff together because we just figured out the coefficients for each term, right? Okay. So on the first term, 6 choose 0, what did we get? Yes, we got 1. Now, we got to figure out 3x to the power of 6, which means not only is x to the power of 6, but so is the 3. So 3 to the power of 6 is? Good, I heard you. 729. X to the power of 6, and negative 1 to the 0 is, just 1. Good. Plus, what did we get for 6 choose 1? Yeah, we got a 6 there. Okay, and now we've got to figure out 3x to the power of 5. So 3 to the power of 5 is, good, 243, x to the 5th, and negative 1 to the 1st is negative 1. Okay, 6 choose 2, what did we get? Yeah, we got 15, didn't we, on 6 choose 2, correct? And, 3x to the 4th, the whole thing. Good. 81, x to the 4th, negative 1 squared is 1. Good. Let's keep going. 6 choose 3. Yeah, we got 20. 3x to the 3rd. Good. 27x to the 3rd. And negative 1 to the 3rd. Negative 1. I'm with you. Plus 6 choose 4. What did we get? Yes, we got 15. And now we've got 3x to the 2nd. Good. That's 9x to the 2nd. And negative 1 to the power of 4. Positive 1. I'm with you. Plus, what was 6 choose 5? Yep, we got a 6. And we have 3x to the 1st. Good, just 3x. And now negative 1 to the 5th is negative 1. Plus, that last term, 6 choose 6. Yeah, that was 1. 3x to the 0, that's 1. Negative 1 to the 6, positive 1. Woof! How we doing? Okay, hang in there. Last step. Now we get to simplify every term. So 1 times this parenthesis times 1. So we have 729 x to the power of 6, correct? And then we got to do this next term, which is 6 times that parenthesis times a negative 1. So you know that second term is going to be negative. Agreed? And that's going to be a negative what? What's 6 times 243? Good. I heard you because some of you are already on your calculators. 1,458 x to the power of 5. That was that one. Okay, next one. 15 times 81x to the 4th times 1. Yeah, it's going to be positive, but you got to do 15 times 81, don't you? What'd you get? Good. 1,215 x to the 4th. Next one is 20 times the 27x cubed times a negative 1. Yeah, that one's going to be a negative. So now you've got to do 20 times 27, don't you? Good. So that's 540 x to the power of 3. And now we've got this next one to do. 15 times 9 times 1. Good. That'll be positive. That'll be 135x squared. This one, yes, that'll be negative when you multiply it. 18x, negative 18x, right? Minus 18x. And this last one is plus 1. Woof! What do you think? Not too bad, right? Yeah, it takes practice, especially finding the coefficients. But you actually know how to do all these terms. So hang in there. Got one more of these. Okay, so let's expand this one. How do we start? Good. Come up with the terms. So my first variable is x squared. My second one is, good, negative y squared. So we have x squared to the power of 4, right? And then we have the negative y squared to the power of 0. Excellent. And then we have x squared to the power of 3. And then negative y squared to the power of 1. And then we have x squared to the power of 2. And negative y squared to the power of 2. And then we have, remember, x squareds are decreasing. So 4, 3, 2, 1. And the negative y squareds are increasing. 0, 1, 2, 3. And finally, x squared to the 0 and negative y squared to the 4th. Whoops, I forgot a square on there. Good? Okay, so after we write the terms, what do we write next? The coefficients. So what's my n? Yep, 4. So 4 choose 0. 4 choose 1. 4 choose 2. 4 choose 3. And last but not least, 4 choose 4. And then how do we attach them? Yep, with addition signs. If it's supposed to be subtraction, it works itself out, right? Okay, so I already got my coefficients figured out. Pause the video, figure out your coefficients, and then restart it when you have it done. Okay, you got them all figured out? Good, let's see if we agree. So 4 choose 0 I got was 1. X squared to the power of 4 I got is x to the power of 8. And negative y squared to the 0 I got is 1. Four choose 1. What'd you get? Good, 4, so did I. And then we've got x squared to the power of 6. Pardon me. X squared to the power of 3, which is x to the 6. And negative y squared to the power of 1, yeah, which is a negative y squared. 4 choose 2, what'd you get? Yeah, I got 6 also, I heard you. Okay, x squared to the power of 2. Good, x to the 4th. Negative y squared to the power of 2. Yeah, a negative to a second power is going to be a positive, and in this case, a positive y to the 4th, right? Okay. 4 choose 3, what'd you get? Good, 4, so did I. Sorry, that's going to bug me, because it was supposed to be yellow. Trying to keep some consistency here. Okay, there we go. And then x squared to the power of 1, x squared, negative y squared to the power of 3. Yep, it's still going to be negative, and now it's going to be to the power of 6. And last but not least, 4 choose 4. Yes, that's 1. X squared to the power of 0, well, that's also a 1. And negative y squared to the power of 4. Good, that's a positive y to the power of 8. Yes? Okay, put it all together. We have the first term, x to the 8th. The second term is definitely going to be a negative, 4x to the power of 6 y squared. The third term is definitely going to be a positive, x to the 4th, y to the 4th. The next term definitely is negative, 4x squared, y to the 6th. And our last term is certainly a positive, y to the power of 8. Good? So the binomial theorem helps me expand these polynomials simpler than writing it out 4 times or even 6 times and then doing my multiplication. But the binomial theorem has another advantage. So hang in there, I'll be right back. Okay, one more advantage of the binomial theorems besides expanding binomials to any power is actually being able to pick things out of the middle of an expanded polynomial without having to expand it. Without having to do all the work and multiplying them out however many times and figuring out which term I'm looking at, I can actually pick out anything I need from the middle without doing the expansion. So let's look at number 4. Number 4 is asking me to find the coefficient of x to the 6th. And this is the binomial that I'm looking at. X to the power of 3, x plus 3, quantity to the power of 10. Okay, how do I start? Just like we've been starting. First things first, you need to pick out the terms. So, your first variable is x. Your second variable is a positive 3, isn't it? So I have an x, and I have a positive 3, don't I? And we need to figure out their powers, right? Well, they told me x is to the power of 6, which means 3 needs to be to what power? If you're going, I'm not sure, remember, they're supposed to add up to the total of 10. So if x is to the power of 6, 3 is to the power of 4. Excellent. Great job. And then, that's right, coefficient is next. So, what's my n in this case? 10. Choose, that's right, 4, the power of variable number 2. So, you got to figure out 10 choose 4. So you guys figure it out. I already have it figured out. And I got 210. X is to the power of 6 and 3 to the 4th. Good. 81. So I got to simplify this. And when I simplify it, I end up with 210 times 81, which is 17,010. X to the 6th. What was their question? They wanted me to find the coefficient of x to the 6th. So the coefficient of x to the 6th is, good, 17,010. That's the answer we're looking for. Cool? Okay, look at this one. They're asking me to find the 5th term in this binomial. And this binomial is to the power of 9. How do we start? Get the terms down. What's your first variable? Good, 3x. What's your second variable? Excellent, negative 2. And you're like, uh-oh, powers. Yeah, powers. Now, here's the deal. I want the 5th term, don't I? Which of these two variables would it be simpler to figure out the power for? The first one or the second one? Yeah, I hear some of you. Some of you are like the first one. Some of you are like the second one. Here's how I figure it out. I look at the second one. Why? Because on term number 1, the power on this second variable is 0. On term number 2, the power is 1. On term number 3, the power is 2. This second variable is always 1 behind on the term. With me? First term, it already has a power of 0. So I already start counting at 0 on term number 1, which means on term number 5, the power of this negative 2 is a 4. It's 1 behind. With me? So if this is a 4, what's the power on the first variable? Remember, they need to add up to 9. Good. That's got to be a power of 5. And now that I've got that figured, now I can find a coefficient, which would be 9. Choose. Good. 4. That guy right there. Right? Okay. So you've got to figure out 9 choose 4. I already figured it out. Pause the tape if you need to. But I got this to be 126. And now I need to figure out 3x to the power of 5. Good. 243 x to the power of 5. And then negative 2 to the power of 4. Good. That's a positive 16. Well, this looks lovely, doesn't it? Okay, so when I multiply all this together, 126 times 243 times 16. Yeah, if you got a large number, so did I. I got 489,888 x to the power of 5. Good? Now, what did they want? Yeah, they actually wanted the 5th term. This is my 5th term right here. Cool? And by the way, just because this ended up being a 5, that's coincidence. Don't go by that. Always go by the second variable, because the second variable is 1 behind the first one if they just want you to pick a term out from the middle. Good? Okay, you have fun with the binomial theorem, and I catch you on the flip side.